Now let us have introduction to curve surveying. A very important definition is the definition which would be defining how much is the curvature, how much is it curving, how much steep is the curve, and that is defined by the term degree of a curve. Now degree of a curve is the central angle formed by two radii drawn from the center of the circle to the ends of the unit chord. Now when I look at the circle over here, if this is my unit chord, a unit chord is a chord of unit length, a well-defined length which is equal to 1 unit. Okay, so AB is the length of 1 unit. So on this circle, when I place this chord of 1 unit, whatever is the angle made over here by drawing the radii from the ends, that is from the end A and from the end B, whatever is the angle made over here, that angle is known as degree of the curve. Whatever may be the curve, I take the unit length and I place it over there. No sooner I place it over there, I draw the radius, and whatever angle has been made over here, has been formed over here, that is called as the degree of the curve. Now, whenever we talk of the English system, say in the UK or the West or even in North America, what happens is this unit chord is taken as 100 feet. It is taken as 100 feet. Now in SI units, system in international units, one chord is taken as one chain length. And now this chain could be 20 meters or 30 meters. So depending upon the chain considered, the chord will be defined. So depending upon that unit chord, maybe 100 feet or 20 meter or 30 meter chain, this degree of the curve is defined. Now, why is this degree of the curve very important to us? Mathematically, the smaller the degree of the curve, the flatter is the curve. If the degree of the curve is smaller, the curve is flatter. Let us look at these two sketches over here. One big circle, one small circle. The unit chord AB, both these have the same length. Now when I have placed it on this bigger circle, from here I have drawn the radius, I've got the degree. I've got the degree of the bigger circle, the green circle. Over here I have placed the same unit chord. Can you observe that this angle is much more than the green one? Over here in the green one, this is much flatter, but can you observe that this is much sharper? That means as the degree goes on increasing, the curve becomes more and more sharper. The curve becomes more and more sharper. As the degree goes on decreasing, the curve becomes more and more flatter. So that's exactly what has been defined over here. Mathematically, the smaller the degree of the curve, the flatter is the curve, and the greater is the degree of the curve, the sharper it is. Also, the sharpness of the simple curve is determined by the radius r. Okay, so depending upon how much is the radius, we can easily understand the sharpness of the simple curve. The curves with large radius are flat, whereas the ones with small radii are sharp. Look at this. Large radius as compared to this large radius, the curve is flat. Small radius, the curve is sharp. So looking at the radius or looking at the degree of the curve, one can easily understand whether the curve is sharper or it is flatter or gentler. So that is exactly what we come to know from this. Let us go further to understand a little more curve surveying. We are looking at the same curve again with AB as the unit chord. Let us assume this unit chord to be about 30 meters. Let us assume this unit chord to be 30 meters. Now in the triangle ACO, sine of d by 2, that's a right angle over here. Sine of d by 2 is opposite, that is AC upon hypotenuse, that is AO. Sine of d by 2 is equal to opposite AC upon hypotenuse AO. So sine of d by 2 is equal to, since this was 30 meters, this will become 15 meters. So that is AC becomes 15 meters divided by my AO is radius. So from here, interchanging, R comes on top, sine d by 2 comes down. So I can write R is equal to 15 divided by sine d by 2. Now whenever we plot this circle on the ground, we know that the ground is large, the alignments are large, the radii are large, and these angles are very small. These angles are pretty small. When this angle is very small, obviously when d by 2 is very small, d is very small, sine d by 2 can be looked upon as d by 2 in terms of radians. In radians, sine d by 2 comes very close to equal to d by 2 if the value is very small of d by 2 of the angle. So we can directly take sine d by 2 equal to d by 2. So in this equation, R will become 15 divided by d by 2. Now we know that this is in radians, but most of our angles, whenever we are doing calculations, they are defined in terms of degrees. So let me convert from degrees to radians. So R becomes equal to 15 divided by d by 2 into pi by 180. So when I do it by pi by 180, obviously this has got converted. So now this d is my degree. From degree I've got converted. So based on this, I get R equal to, this is in the denominator of denominator is 2, denominator of denominator is 180, 2 into 180 becomes 360, that goes on top. So R is equal to 360 into 15 divided by d divided by pi, or R is equal to 1718.9 divided by d. Or a very important relationship which we get over here is R is equal to 1719 divided by d. So looking at this particular triangle over here, I have got now a relation between the radius of the curve and the degree of the curve. Radius of the curve and the degree of the curve, considering that AB is 30 meters. And what is that relation? R is equal to 1719 divided by d. R is equal to 1719 divided by d. Or radius of 1 degree curve is 1719 divided by d approximately. 1 degree curve radius would be 1719 divided by 1 over here approximately. Now what is 1 degree curve? 1 degree curve is the curve or circle formed when an unit chord, that is AB in the figure, subtends an angle D which is having value of 1 degree at the center of the circle. This angle becomes 1 degree. So for that, what should be the radius? If this angle has to be 1 degree for 30 meters over here, what should be the radius? That will be 1719 divided by 1. That means 1719 meters. So if the unit chord of length 30 meters was taken, if unit chord of 30 meters was taken for a 1 degree curve, then for every 30 meter chord length, 1 degree angle would be changed at the center. So this is 30 meters. Suppose I want to put another 30 meters over here, obviously angle would be another 1 degree. Another 30 meters, angle would be another 1 degree, and so on. So for that unit chord, whatever is the angle, no sooner I increase that unit chord, that much amount of angle will be swiped at the center. Similarly, from 1 degree curve, we can have the definition of 2 degree curve, 3 degree curve, and so on.